Right. That's what no one knows when I start my recording is they don't know what happened before and they don't know what happens after. And I like it that way. So today's the 21st, and I hope that this does not take long. What we're going to learn first is to find the distance between two complex numbers. And this part, I'm going to just kind of take this off the assignment. I hope you don't, this was intended to be a beneficial thing. When I look back at it, I thought, God, I hope this formula doesn't like turn this into something that they think is like more difficult than it should be. But if you have a complex number, you'll see this as we do a little bit more. Complex numbers are often named with letters. So like if a complex number's name is Z, and in the worksheet that I gave you, the formula I gave you, I just called it Z sub one. So that just means he's my first complex number. His name is Z, but because he's the first one, I'm going to call him Z sub one. Good. So if I have a complex number named Z sub one and his like meat and potatoes, his substance, his essence is A plus BI. I love it when that air conditioner goes off. It's so quiet and peaceful. And if I have another complex number whose name is Z2, again, nothing fancy. He's just the second complex number. And his name, if you will, or his substance will be C plus DI. Anyone confused yet? These are just a pair of complex numbers, right? It could be anything that we want. So the distance formula, the distance between those two complex numbers is, do you guys remember the distance formula maybe from last year or whenever you took geometry? It's something like that. You're going places with this, yes. No, there's no over with distance. You're thinking yeah, good job. So the distance formula is just a whole bunch of math and one big root. What it winds up being, and I hope you don't leave high school without understanding this. Like maybe your understanding already happened, but the distance formula is really just a snapshot of the very tail end of the Pythagorean theorem. So much in math is the Pythagorean theorem in disguise. We've already seen it this year. So the distance formula says to take and find the it's again, it looks harder than it is, but you're going to take C minus A, square it. Like in your guys's past with this, it might have been like x1 minus x2 or something like that, right? And then we're going to add to that the quantity of, you want to guess what the next one's going to be? Just D minus B. You don't worry about the I because really what we're going for is like literally a physical distance. So what I'm in that, if I looked at that, depending on my age, I might look at that and think, oh my gosh, that just really got difficult. What it really boils down to is if you have two complex numbers, let's take a look at a couple of complex numbers. Just example, I won't like do anything specific. We'll just keep it simple. So let's say that we had, we'll call this, the red point will be Z1 and the yellow point will be Z2. So if I just plotted some random complex number out here, Z1, and I put it like there, not even going to give it a name or like numbers or anything. And then let's say that I plotted Z2 like right here. Good. When you really think about what's happening here, and this will probably be similar to the explanation that Mr. Manlove gave you when we were just working in the Cartesian plane with normal points. And that is, I mean, really think about what C minus A is. We all agree that A and C, they're kind of like the X coordinates of a complex point, right? A complex number, right? They're the sidewaysy numbers. And so when you look at the yellow and the red point, when you think of C minus A, you're essentially just finding this horizontal number minus this horizontal number, aka the length of a triangle like that. You see? It all comes back to the Pythagorean theorem. And then when we do D minus B, you agree also, I hope, that the B and the D values, like the imaginary coefficient, is just like the Y coordinate of a point. Simple. Simple when you're ready for it to be simple. And then you think about that and you say, well, if I do D minus B or B minus D, the order is irrelevant because we're going to square it away anyways. That is this vertical coordinate and this vertical coordinate, aka that side of a triangle. So if that makes no sense, you'll still be fine. The point, though, is that it's all just related to a triangle, Pythagorean theorem. Because what we're looking for is the distance between the 2 points, and that is represented by this white line segment right here. That's what we're going for. So the distance formula just is nothing new. It's just a snapshot. That's all it is. Any questions about that? So we'll do an example of that here in a second, but I also wanted to show you the other thing we're going to do today. And so that's your distance formula. And then there's also a midpoint formula. So the second half of this, and then we'll just, the assignment isn't broken up. It's like here are 2 points, find the distance, find the midpoint. So like each problem, you do them both. So let's just learn them at the same time. So the midpoint, math people get this and they get it quick. You understand like just intuitively why it works the way it does. Again, let's look at the formula first. And this is the one I think, Brady, you might have been trying to get at, right? So if you have 2 complex numbers, and again, we'll call them, you don't have to write them again if you don't want to, but Z1, the first complex number, can be like A plus BI. And then Z2, the second complex number, would be, again, C plus DI. Just like, what is a midpoint? Yeah, bless you. Exactly. So like if I have 2 complex numbers and I plotted them in the complex plane, the midpoint is the point that's halfway on the line segment that you draw between the 2 of them. That's all a midpoint ever is. That's all it's ever has been. And so the midpoint formula is capital M, and it is a complex number, so it's going to feel a little bit different. And there's a little typo on my sheet. I'm not going to count that against myself because I don't count. I'm going to try to justify that not being an actual, because I never mind. Anyways, the midpoint is a point, but it's a complex number. And so the way we write it is we take the A and the C, we add them together, and Brady, we put them over 2. What happens in math when you add 2 numbers and divide by 2? You get an average, is what we call that. So that's really, again, I'll show you a picture of why this works, but all we're going for is like, what's the average real coordinate, like between the 2, the average X coordinate. And then we're going to put a plus sign here. That's where the typo happened on my worksheet. So sorry. So plus, and then what is the imaginary part going to be? Just B plus D. Yep. So we're going to do B plus D. And again, we're going to divide by 2 because in math, if you divide a sum by 2, you get an average 100% of the time. If you add 2 numbers, divide by 2, it always works. And then you do slap the I right there on the back. So that is what your complex midpoint will look like. And that's that. So let's do a couple of complex numbers. Let's, or how about this? How about to get towards our goal? Let me hand out today's assignment and we'll do the first problem or 2 together. How's that? We'll get closer to our destination. I'll keep the recording like paused, but I'll bring it back on while we do the problem. And let's do problem 1 together. So we've got a pair. I'm not going to ask you to graph anything if you don't want to. You can, but you don't have to. So we want to find the distance between the 2 complex numbers, and their names are 2 plus 3i and 5 minus 4. Again, the formula can look really daunting, but at the end of the day, it boils down to very, very basic skills. Can you subtract? Can you square? And can you add? And of course, can you work with square roots? Pretty basic stuff though. So what does the midpoint, excuse me, the distance formula say that we need to do first? And let's try to avoid x2 and x1, and let's stick with our complex notation. How about c minus a? Does that work? And I don't disagree with you, just let's try to stay in the same realm, even though it's very related. So we're going to start by doing 5 minus 2. And we're going to square it. And if you don't want to show that much work, I do not care. Next. So I'm going to put a plus here, and then I'm going to introduce a set of parentheses. And again, it's just going to be, it's robotic. It's going to be one of the imaginary coordinates minus the other.
Please excuse the directions. We need Bryland McCorkle to the office.
I've never heard of that person before. And then we're going to put a big square root sign over it. Right? Just not a lot of meat on the bone, so to speak. It's just repetitive. It's formulaic. So now we got to do some math. What's 5 minus 2? What's 3 squared? Good. So we have the square root right now of 9. And these are always going to be positives because we're squaring. Right? So that's never, you never have to worry about like subtraction here once you're done. What is negative 4 minus 3? Negative 7. And what's negative 7 squared? So we have 9 plus 49. So the if you graphed these two complex numbers, which I said you don't have to do, but if you did and you eyeballed them, they would be root 58 units apart from each other on the complex plane. What is that roughly as like just a regular number for us normal folks? 7.5-ish, right? Something like that, 7 and change. So that's what that is. And you cannot break that one down. The only factors of 58 are 2 and 29. So that would be a final distance. So we could say the distance D equals that. Done. There's not a lot of room here. Sorry about that. I just didn't want to do front and back. Now we have to find the midpoint as well. So let's stay with the same set of complex numbers, but let's switch over, transition over to the midpoint. And you'll want to ask about decimals and all that. And I really, in this context, don't much care because the decimals we get are all going to be super sweet. 0.5s are stress-free, so I don't really care. So what do we do first to find the midpoint? So I'm going to take, again, what you think of as the x's, the a and the c, the real parts, and I'm going to add them together. What's 2 plus 5? 7. So I'm going to do 7 over 2. It's going to be my first. And again, we can talk about how you want to write that. No big deal. Let's head over to the other ones, the b and the d. What's the next step going to be? Yeah, -1, right? So like 3 minus 4, 3 plus -4, 3 minus 4 is -1. So that's just negative. We got to divide it by 2. So I would be fine with this. I would actually love this answer if you wrote it as 7/2 minus 1/2 I. That's to me the most like delicious answer that you could give. If you just have always wanted to use decimals, like finally I get to use decimals, then you can write it as, 3.5 minus 0.5 I. If you really like mixed numbers, you could write it as 3.5 minus 1/2 I. I guess what I'm trying to say is that's not of great concern. Okay, so there you go. We did it. And we're going to want to write like M, capital M equals. So what's in that white box to me is the best answer, but the others are just. Any questions on the process? Do you feel like you're ready to go? Can you handle it? Okay. Well, I'll pause the recording if you want to go over anything. Hey, do me a solid and look down. Notice in the fourth problem what's weird. It's just 5i. It's a pure imaginary. What does that mean the real is? 0. Put it in if you want. And I scattered those in 3 times. They're right there in a column. There's the fourth problem, the sixth, and the eighth all have a little bit of weirdness. So don't panic, okay? If it helps you put zeros in. The fourth problem, we have 8 plus 7i. And we have 0 plus 5i, which you certainly don't have to add the 0, but I think just having a placeholder there would help. Did that already answer your question, you think? Okay. So I would do that on the fourth one. I would do it on the sixth one. I would do it on the eighth one. Having the 0i or just the 0, whatever, I think is going to hold you together. Better? Okay.